This is problem number 3 from section 9.3. In this problem, it says to solve the following system of equations in 3 variables. You'll notice we have 3 equations, 3 variables in the first. It's missing the z term in the second. We're missing the y term in the third. Okay. We know to solve systems of equations, we can graph, we can substitute, we can eliminate, and we can use matrices. Now for these problems, I'm typically going to do a mix between substitution and elimination. Like I'm going to do the problem sometimes using elimination and then might switch it up to substitution in the middle of it. So these two can kind of be used together as we go through. Here's my steps to solve these systems, and this is what we're about to do. We're going to cancel a variable in the first and second equations. Then we're going to cancel the same variable in the equations 2 and 3. We're going to use the 2 equations you created to solve for one variable, and then we're going to reverse substitute to find all our answers. So let's go ahead and start. Just going to throw this up here to the right, that way that we've got that sitting there. Okay, start with equations 1 and 2. I want to cancel a variable. So I'm going to cancel, because I see this bottom equation does not have any y's here, I'm going to cancel the y value here. Okay, so I'm going to take x plus y. So I'm going to say cancel y. I'm going to take x plus y plus z equals 61. And I'm going to take negative 2x plus 5y plus 0z equals 68. And I'm canceling the y value, meaning I'm going to take the top equation and multiply it by negative 5, leaving me with negative 5x minus 5y minus 5z equals negative 5 times 61, negative 305. Then I'm going to add this together. So remember, I'm using the elimination method right now. So I add this together. That's negative 7x. This cancels. This is minus 5z equals negative 305 plus 68, negative 237. Now, step 2, it says cancel the same variable in equations 2 and 3. However, my equation 3 already has x and z in it, right? So I don't have to cancel a y value. I already have another equation with x and z in it. So I'm going to just take this equation along with x minus z equal negative 9. And I'm going to, I screwed that up. This is 237. And I'm going to cancel now. I'll say I'm going to cancel the x value. So to do that, I'm going to multiply the bottom by 7, leaving me with 7x minus 7z equals negative 63. Can kind of cross that out. We're going to add these equations together. When they are added together, that's 0. That's negative 12z. And this will be negative 237 and negative 63. Gives you negative 300. We're going to now divide negative 300. Divided by negative 12. Gives you 25. So z is 25. That's one of our answers. I'm going to circle it. Now we're going to start to reverse substitute. All right, because we just took our 2 equations and combined them together, we're going to reverse substitute. So I take z is 25, and I'm going to plug it into one of these 2 equations that I had right here. And actually, I'm going to use the original x minus z equals negative 9. So I'm going to say x minus z equals negative 9. So x minus 25 equals negative 9. Add the 25 over, so x equals 16. And then I pick one of the equations at the top with 3 variables, so x plus y plus z equals 61, and I say x plus y plus z equals 61. And I can now plug in my x and the z. So 16 plus y plus 25 equals 61. Subtract, or actually let's combine like terms, y plus 41 equals 61. Subtract the 41, you get y equals 20. So the coordinate that's a solution for this system is 16 for x, 20 for y, 25 for z. And that's how we solve a system of linear equations in 3 variables.